Hey, what's up everybody? Welcome to this video. We'll be talking about the try except block. In the previous video, we introduced ourselves to exceptions and learned about the different types of exceptions. In this video, we'll see how we can handle those exceptions using the try and the except block. So if that sounds interesting, let's dive right in. This is the code that we had from last video. If you are new, don't worry, I'll just explain each line. So these first two lines, we are prompting the user for input, and the input will be stored in this number1 variable and number2 variable respectively. Then line 4 takes number1, divides it with number2, then stores the results in this quotient variable. Then in line 6 we print the quotient of those two numbers in the terminal. If you run this code, for example, I run it to 10 and 2 or 10 and 5 like we did before. So I'll just say my first number is 10, my second number is 5, then the quotient of 10 and 5 is just 2. But if I run the same code with 10, then with 0, you see we got an exception. And this exception is called the zero division error. That's what we did in the last video. So in this video, you'll see how we can handle those exceptions using the try except block. The very basic way in which you can handle this exception is use the try except block. So to do that, you just surround all the code that you think it's dangerous, you just surround it inside a try block. So to create a try block, here's the scene, just write try full colon, then the code that you think might raise an exception, then you put except, then the code to handle the exception. So I'll just write a try here like that. Then in this case, I think all this code are dangerous, so I'll just put them inside the try block like that. Then here I'll put my except block, so I'll try except. Then let me just write exception, but we'll discuss about this some minutes to come. Then here I can just say maybe print something went wrong like that. So now if I run this code, let me run it with 10 and 2 first so that you can see it just works fine. So if I run it with 10 and 2, if I just say first number is 10, the number is 2, you can see it just works as you expected before. But now if I run it if I try to divide with 0, if I say first number is 10, second number is 0, you can see now the exception was handled. You can see there's no exception here, but this except block was run and it told me that something went wrong. So how this try except block works, the Python will first by running this code. If this code works well without an exception, it will just execute as you have seen the first time that we ran it. But if Python runs this code and maybe there's an exception, it will just cache that exception, then this code will be run. And that is the most basic way of how you can implement try except block. So the problem with this is that it works correctly, but the problem is it will just catch all types of exception. In the previous video, we discussed about the common types of exception. So it's good practice to catch a specific exception type if you know it. And in this case, you already saw that maybe you can just run this code again without this try catch. But you have seen that the exception is called zero error. So I can just say here, I can just say this except will catch, it will be a generic, it will catch all exceptions. Maybe before it, you can just put another except here and you accept the zero division error like that. Then maybe I can just print a generic response, because I know this one will just be run if the exception is a zero division error. So maybe I can just print here cannot divide by 0. So how this will work is that Python will run this code as usual. If it's okay, nothing will happen. But if this code raises an exception, and that exception is a zero division error exception, this code will run. But if that exception is any other exception, this acts like a catch-all. It catches all other exceptions. So if I save this code and maybe I run it, you'll see now, maybe I enter first number as 10, then the second number is 0. You can see it tell me cannot divide by 0. That means that this block, the first except block, is the one that was run. That is because that error was a zero division error. So this except block caught that zero division error. But if it was any other error, it will be caught by this except error. And I think that one is just clear. So let's say let me just run the same code. Then let's say this time someone puts something that is not a number. For example, I divide 10, or I can just put I say something like pizza here. So you can see it will tell me something went wrong. because pizza is not a number. This input accepts a float, and I typed in a string. It's a pizza which cannot be converted into a float, so it will raise an error. And we saw in the previous video that's a value error. So if I wanted to catch that error, you can see currently it's caught using this exception. So if this exception was not there, maybe I can just let me just comment this out and run this code again to show you the error that we encountered there. So you can see now we are only catching the zero division error. So that means if you have any other error, it won't be caught by our except block. So if I enter something like, let's say enter pizza, to tell me that's a value error, because pizza is not a number, cannot be converted into a number. So to handle this, it's not good practice to use this except block. Like I said earlier, you should handle each exception by itself. So I can just get another exception here. Allow me to just duplicate this. Then maybe I can call this exception, we have said it's called value error, so I'll just say a value error. So this is another type of exception. Then you can put its statement here. For example, I can say maybe only numbers are required. Like that. So now if I save this same code and run it, and then I put maybe a text that cannot be converted into a number, I'll get that only numbers are required. So if I say something like pizza, you just tell me only numbers are required as input, and that is how you handle this error. But you can just leave this as a catch-all, just in case an error occurs that you didn't handle. This will act as a catch-all, just like we saw before. An additional way in which you can handle these exceptions is that we could display the actual exception as it occurs. Although it's completely optional, but let me show you how to do that. For example, let's say I want to display the actual exception that occurs if there's a value error. So I'll just say here as E. Then someone might ask, why do I say as E? You can just put as any letter or any name, but this E is the convention. So you can just print that E to see what that is. So maybe I can run this code to show you what I've just done. So if I run this code, and that was for, I think it was value error. Okay, it's value error. So let me just put something that will raise the value error exception. So if I just say here pizza, it will just tell me could not convert string to float. Then it's giving me the thing that I typed there, pizza. So this E it gives you access to the actual exception and gives you that. And in this case you have printed it, so it will just print there. Then our print statement that says only numbers are required will just be after that actual exception. That is how you use this as E. But as I say earlier, I can just give it any name. Maybe I can say something like maybe any name. Just let me say R. Maybe you can just print R. And if I save that code and run it, it will just work fine. But as I told you earlier, that the convention is with the E. So if I just say here, let me say done, it will tell me could not convert the string to float, and that string that I provided was done. So you can see even if I put any letter or any word, it will just work fine. But I'll just maintain E because E is the convention. So that is how you handle the basic exception. But the other thing that you can do, as you can see here in the notes, is you can add an else statement at the end of the exception. So what this else will do, in case there's no exception, this else will just be executed. So I can just put here else. Then maybe let's just print this. Let us move this print statement to else, in the else block. So yeah, so what this will do, it will try this. If there's an exception, those exceptions will be cached, and there'll be these errors, these statements will be executed. And if there's no exception, we'll just print our quotient. So this else is executed if the try block does not raise any exception. So maybe let me just save this code and run it. So let me try with an exception first. So maybe I can just try dividing by 0. So maybe let's say 10 divided by 0. There's an exception that will tell you cannot divide by 0. But now if I don't do anything, if I just say 10 and I put there 5, you can see it will just tell me the quotient of 10 and 5 is just 2. That is to show that this else was ren, and this else is only ren if the try block does not raise any exception. So if this try blocks raise an exception, we'll try to see which exception it was and print the custom error, the custom message. But if there's no exception, this else will be executed, and that is how you use the else clause. Another clause worth noting is this one called the finally clause. And with this finally clause, the code inside that block will be executed regardless of whether an exception occurred or not. It's often used for cleanup actions like closing files and releasing resources. But since I've not learned about the files, I'll just come up with something that will just show the finally. So this is usually the last block in this try except. So I'll just write there finally. Then I can just come up with a simple, let me just print this code will execute regardless, or I said this line. So finally, whether there's an exception or not, this line will still execute. So let me just run this code to prove that. So if I run this code, let me just work this well. So I'll not provide anything that will cause an exception. So I'll just say something like 10 divided by 5, which will just be 2, and you can see this finally will just execute. You can see to tell you that this line will execute regardless. I missed the spelling there, but no problem. So if I run the same code, and now this time I want to raise an exception, let me raise the division by 0 error exception. So it will just tell me cannot divide by 0. So you can see the code, this else was not run because there was an exception, but this finally will run regardless whether there was an exception or not. And that is how we use this try, except, else, and finally blocks. And I believe that was good. You'll use this finally with files mostly, especially when trying to close a file, because when working with file, once you open that file and maybe you didn't successfully do something, you always want to close that file. To summarize, an exception is just an event which occurs during the execution of a program, and that event disrupts normal flow of the program. So you have seen how we can handle the exceptions, but in the next video we'll see how we can create our own exception and we can raise exceptions by ourselves. So see in the next video we learn about the custom exceptions. So see you there.